Hi everyone. Today we finally get to start talking about our first unit and our first topic in astronomy for our class Earth and Space Science. I'm really excited. We finally get to get into some new material and look at how the electromagnetic spectrum, which we just finished reviewing, comes into play and is important in allowing us to observe some things in space. So let's get into our notes here. All right, so our topic today is just going to be astronomy. Our essential question is, how does the electromagnetic spectrum positively impact Earth's systems? So if you're following along, this will go on page 12 and 13. Your topic and essential question will go on page 13. And let's get started. So astronomy, okay, as we already know and we've already discussed, is one of the four major branches of Earth science. Okay, again, astronomy is the scientific study of the universe and Earth's place in it, right? We look at all this space and all these different celestial objects, and then how Earth interacts with those things as well. Okay, so our first big thing that we're going to look at is a galaxy, and we have a picture of the Milky Way here, which, if you remember, we mentioned it on one of our worksheets previously, that the Milky Way is a spiral type galaxy. And there's a few different types of galaxies that we'll get into eventually, but a galaxy is just a collection of stars, dust, and gas. All right, and these are one of the things that are formed early in the formation of the universe. So when we're talking about some of these celestial objects and distances and things like that, one of the things that we need to incorporate is a unit of distance. And the unit of distance that we're going to use for now is the astronomical unit. And now the astronomical unit is the average distance between the Earth and the Sun. When we're looking at our solar system, we don't really want to use meters or kilometers because, well, some things are further than the distance between the Earth and the Sun, and we would be using many millions of kilometers. So instead, we use the astronomical unit, which is the average distance between the Earth and the Sun, which is about 150 million kilometers. So here's what I want you guys to do first. I want you to do a little bit of research on space telescopes, okay, and particularly the Hubble Space Telescope. I have, if you're following along on the PowerPoint, I want you to use these sites as resources. So I have the links on the PowerPoint here for you to use. And on the left page of your notes, on page 12, I want you to find 6 discoveries, 6 things that the Hubble Space Telescope has discovered. And what I want you to do is I want you to include the name of that discovery and then how Hubble made that discovery, right? And for how it made that discovery, I don't want you to put it saw it, it observed it, right? I want you to write down what exactly the Hubble observed. Okay, how did it notice that? Something had to happen. And so you'll tell us a little bit about that discovery. Okay, so a couple other resources here that I have for you. Okay, there's a link here for an article as well as here. Okay, and then a page in the textbook, which I actually have the link here that you can use as well in the PowerPoint. So go ahead and pause the video. I want you to work on those 6 discoveries from Hubble. And once you're done with the 6 discoveries from Hubble, then we'll continue on with our notes. So go ahead and pause the video and I'll talk to you in a minute. All right, now that you have written down the 6 discoveries that you found, hopefully you found something interesting. Hopefully we'll get an opportunity to share some of those in class. So we're gonna continue on with our notes. So we wanna look at telescopes, right? I had you look up some things on the Hubble Space Telescope. Well, let's take a look at how that actually works. So we need the electromagnetic spectrum, okay? And those light waves travel through space, and we're able to actually collect those. And one of the ways we collect those is in a refracting telescope. And a refracting telescope is a telescope that uses lenses, okay, to gather and focus light from distant objects. And we can look at it here. The light comes in, hits the objective lens, okay, and it refracts or bends the light, okay? Remember refraction and reflection, okay? We can reflect light and we can refract it or bend it, meaning it will go through whatever medium it's traveling through. Okay, so it bends the light, refracts the light, and then it hits the eyepiece lens, okay, to then focus it for us to be able to see. That's how a refracting telescope works. It uses a couple different types of lenses. A convex lens, okay, is curved outward. Okay, it's an outward curving glass lens. That's the one that focuses the light. A concave lens is curved inward. And a way to remember that is concave, right? It's curved inward like a cave. Okay, so a curved inward lens. And that helps to magnify the light. All right. So a refracting telescope, okay, like the one we just looked at, okay, is usually cheaper than a reflecting telescope. And we'll get into why that is here in a minute. Okay, it's usually cheaper. The problems with this type of telescope is that it's difficult to make a very large objective lens. Okay, and remember that objective lens is that very front lens in the telescope. It's hard to make a very large objective lens with the strength and clarity that would be needed to really see these really far out objects. Our next type of telescope is a reflecting telescope. And so, as you might have guessed already, instead of bending the light, okay, it reflects the light. And we can use different types of mirrors to do that. So a reflecting telescope is a telescope that uses a curved mirror. Okay, it gathers and focuses the light from distant objects. So we can see that the light comes in and there's a concave mirror in the back, okay, where it reflects that light back to a flat mirror and then goes to the eyepiece for us to be able to see. So this F right here is the focus. Okay, that's where all the light collects, and that's where we actually see the object that we're trying to observe. Okay, a reflecting telescope can be much larger and can gather more light than a refracting telescope. Okay, so it can be large. It's easier to make those a little bit larger and can collect more light, meaning we can see things a little bit better and sometimes at further distance. So space telescopes, okay, a lot of times we launch these telescopes into space, such as the Hubble. The Hubble was launched in 1990, 89 or 90, if I recall. And we launched those into space to collect the light and electromagnetic radiation from objects in space. And one of the reasons we do that is because there isn't all the light pollution that we have on Earth and the atmosphere and things like that that can also bend and distort light. Okay, when we send those out, we can see some really cool things like exploded stars and black holes. Okay? So another thing that I want to mention about the comparison between reflecting and refracting telescopes, and this is important, you may want to add this into your notes. It's the reflecting telescopes, those reflecting telescopes that use mirrors are more expensive, okay, because of that mirror has to be without imperfection. And it's clearer, the reason it has more clarity is because you only have that surface, okay, that mirror surface that you have to keep free of imperfection. With a refracting telescope, that refracting telescope, the light goes through a lens, meaning the medium that makes up that lens has to be free of imperfection throughout the entire construction and the entire medium of that lens. So keep that in mind. You may want to add that to your notes. All right, so next thing that we have to do is we have a web quest. So a James Webb telescope is a newer space telescope that we have launched into space. The website here is linked for you to access that website. And on the outline for the class, I also have the worksheet for you to do. So that's going to get turned in to the Dropbox on Google Classroom. Okay, once you're done with all that, then we're gonna wrap up this first topic for Unit 1, and so you can complete your questions and summary. If you have any questions on any of this material or any questions on some of the expectations on some of the classwork that we're going to be doing, please don't hesitate to send me a message. I will talk to you guys soon. Thanks.